Well, this is the second part of the find where we are going to look into the query DSL, which is an important concept. So till this time we were using the repository queries and writing the MongoDB queries and passing it as query in the repository layer. But the debuggability of it and if something changes in the database, how are we going to change it? It becomes very difficult. For example, if some fields are getting manually added, how do we ensure that changes are getting reflected here? Because it's loosely the schema is loose, right? So it's not strictly enforced that this is the document that we need to, this is the type which has to in MongoDB as of now. So although there are possibilities, but for this we are not doing that. So let us look into how do we ensure this type strict way of querying, so that anything which is inserted over there in the database will also get reflected over here, and the data schema remains consistent while we are querying. So let us look into how query DSL is going to help us. So although it helps us, query DSL helps us to the querying fast, we have to do a separate setup for it. So that is why if you are seeing the screen of um, Gradle build.gradle, we have to include this plugin dependency, which is com.avir.gradle plugins.queryDsl. Whatever is the latest version, you go ahead and include it. The other thing is, while the query DSL supports a kind of annotation kind of thing, right? So how we are going to do it is this is the compilation time what we have to do, and it says that use this configuration and the annotation processor part. So we have Lombok, which is also an annotation processor. We have to have the query DSL, which is also an annotation based thing. So it injects a lot of things over there, so we need to give this. The third thing is query DSL, we have to generate, it says that generate the query DSL for JPA. Right now we are not using, but I'm just saying JPA equal to true. And Spring Data Mongo also generate the query DSL classes and the query DSL source directory. So where it has to generate these classes means the source code. So it is in the build dir generated source main. If we go to our build dir, which is, and then this is the build folder, notice generated source main is the same package that we have, which is the model. We have a queue access, queue contact, and queue phone. So for every parent document it generates a class, for every sub document also it generates a class. So it is the same case as we have in the model. What are the other dependencies that we have? Compilation dependencies, query DSL MongoDB, query DSL JPA, and query DSL app. These are the three dependencies that we need to add. And if you notice it clearly, we already had annotation processor of Lombok, which is getters and setters. We have added annotation processor, which is query DSL.apt, and add this query DSL only as compile time only, because these classes are getting generated at the compile time. These dependencies are not required at runtime. If you change it to compile and have it as compile only, if you change it to compile, it will throw some runtime error. So please be careful in doing it. And why I am explaining this Gradle, because I have struggled a little bit to set up this Gradle environment for query DSL. For others who are following this tutorial and you are using Maven, it is straightforward. Whatever is there in the internet, just copy paste. It is going to work in the documentation. Query DSL documentation, it is clearly mentioned that how do you have to use it in Maven. There was no clear tutorial for how do you do it in Gradle. So if you want to look into it, take my source code, which is available in the github.com/gopalbala/contact service. So use it. So that is why I'm explaining why we have to do. The generated source dir is what we are saying. So before doing it, generate the source dir is what in the first step while compilation, and we say that the source dir minus s, the Java C. If you go to Java C and put minus s, it will give what is the why it is required minus s. It says that this is the option to specify the source DA or source files. So while doing the Java compilation, use these classes also. Use these class files also is what we are saying, not the class files, the source code files. If you want to look into how it is, Java C option here. If you see Java C minus s directory, specify the place where to place the generated source file. This is what we have to place the generated source file, and this option is what we are saying. So these are required for us to run the query DSL. It is not trivial, but the effort that we put is going to be useful while we start using the query DSL for query, because it is so easy to use query DSL while we query. So what is that? We go to the query repository. In the query repository, if you see, there are no additional methods that we have written. Repository remains repository as is. If you see, for query DSL we have 4-5 methods. Let us go to here. So query DSL, we are going to look into 4 get methods. For those 4 get methods, we do not have any specific repository functions written. Nothing is there. So what we have done extra, query DSL predicate executor is what we have added. For the existing repository, just add the query DSL predicate executor and tell what is the type. We have the document that we are going to insert is type contact. Just say this, and it will give an option of find all by predicate. So let us look into how are we going to build this predicates and other things, how query DSL is going to help. Yeah, let's directly go to the query DSL service. As usual, we will build based on interfaces, contract event. First method that we are going to look into is find by name. Let us look into how did we implement find by name in the query service repository and the query repository. We say that find by name, like this is how the MongoDB repository says. We are not writing any code, but yes, still we say that you just have to build this function in the way where it is. So we have to say that find by what is the field name and what is the type. This I have already explained. If we have to be skillful in learning this, how are we going to query this? The next thing, in the query repository, what are we done? So we are writing like a query like this. So it's not first name, but let me take another simple example, right? Query address.city. Similarly, first name, which is a regular expression, starts with this is what we are going to give first name. Or address.city, which starts with this is how we need to go. You see, these are difficult. These are not the easiest ways, and this is not in sync with the document in the database. So let's directly go into the service implementation class. So as we build this, right, if we go and execute in the Gradle, similar is that if you go to the build.gradle file, there will be a query DSL. Compile query DSL. If we say compile query DSL, that all the query DSLs are generated. This is the one which generates this queue address, queue contact. So all the output classes will be having queue as a queue prepended to it. So we have a contact which is prepended. This is a query class, right? So it's a queue contact. Queue address is a subdocument and phone is a subdocument. So it will have a queue prepended implementation. Let's go to the implementation. Since this is a implementation class, we implement the service. We are auto-varying the repository layer, because in the repository layer we have just included the query DSL predicate executor. So we are going to build predicates and then execute it. So this is the first method we are going to look into. Queue contact. What are we going to search? In which document we are going to search? Which is the query contact. We are just creating a new query contact. We are just creating a new object of the query contact. The first thing, you just give any name. It doesn't matter what name you have to give, but you just give a meaningful name. We are just querying by first name. Instead of name, you can give first name. So predicate, we are building a predicate which is a first name, which is a first name predicate. This is the contact, and then contact contains an attribute called first name, which starts with first name. It looks very easy to build this, am I right? And what it is going to return, I am saying the contact repository which has a find all method. If we say find all method which takes in a parameter of predicate, so suddenly this predicate builder comes and use this predicate builder to find, it returns an iterable. This is important thing that we need to look. So iterables are read only and forward only. So what we need to do, so iterables, I have to map an iterable to the list of contact details. So I have used the stream support because iterables doesn't support stream. I am using a stream support dot stream and pass this iterable and get the split iterator of it, and it says parallel equal to 2. So I am parallelizing the read only and forward only. Because it is a read only and forward only, you can parallelize it. If it is if you are going to do some modification, we should not be doing parallelization most likely, but since it's a read only thing and I am just mapping to a new object, I am just parallelizing it so that the result can be faster and collecting to a new list. Because it is not, iterables are not like list, it doesn't conform to the stream interface. We have to use the stream support dot stream on a particular collection to do it. This is a new learning that you might have to look into it and take a look into what stream support does. Just go through it. If you already know it, it is good, but it's a good thing to know about stream support. So what we did, this looks very easy, and any model change which is there in the, if we are going to insert new values, the model of contact model will undergo a change. When the contact model undergoes a change, when we do a compilation, Q context will be generated. The Q contact will obviously reflect the new properties, and when new properties are added automatically, we will be able to find by those new properties. So this is the advantage that we are getting. Our code becomes readable. There is no custom queries that we are writing, which is little difficult to test. And the third thing is the sync between the document and the model is maintained. Let us go into the controller, contact DSL controller. So I have created a new DSL controller which takes in the contact first name slash first name. It returns as usual as a JSON. I'm just getting a response entity, and the query DSL service is the interface that we have built, and we are auto-varying the implementation here, and I call the first name. So let me run this. It is not running. When we go to the install testing tool, find by first name, let's say do I have a name which starts with, I think, G, right? Let me send. We did not try this. It is starting. Okay, we did not run. I'll run the task to create the query, the DSL classes. So now I'm executing the code. Okay, it has started. Okay, so we have two names which is starting with G, which is Ganesh Kumar and this Gopal Sai. These are the two contacts whose name starts with G. With this, let us look into the second thing. And suppose that if we need to build a sort, right, it is easy. So let us see how do we build sorting here. So if this find, okay, not here, let us go to our service implementation layer. If we take it find all takes a predicate and a sort as well. So we can have sort. So the result has to be sorted, right? If we think that the result has to be sorted, we can pass it. So how do we build a sort? Let us look into it. It is called Q sort equal to Q sort. So we have to do Q sort equal to q sort dot by q contact. We are going to say sort by the contact, which is a contact where first name dot descending. So this is the sort. So we have just built how do we need to do order by. Simply give the sort expression here. Okay, so now the result is sorted. So we are going to find the name, sort it by first name in the descending order. So let us run this query and see how that works. It's so easy, right? So it's easy to build such kind of sorting, ordering by. So order by is very important thing. So you can add order by multiple fields as well. Let us look into that later. So the predicate gives us a easy way to do the ordering and filtering. So let's send again, which says that GO is the first name, GA is the first name. So GA comes second, GO comes first. Now I will stop this and say ascending. Yes. So now we are trying to order by ascending. Let us see if we are able to do it. Let it run. This compiling, generating classes. Okay, it started. Now Ganesh has to come first. Yes, GA comes first, Q comes second. So it is easy to build such kind of sort expression. So whatever we have done, it is coming as a query here. So it's easy to debug this as well. So let us look into the second thing. We are going to find the person by state. State is in subdocument. So what is the significance of this? The state is in the subdocument. So if we look into the subdocument based queries in the query service repository, so we are seeing address dot state, which is regular expression. It starts with and question mark 0. This is not easy to build, and it is easy to make mistakes and then get lost. For example, if something of a single quote is missed, it will become very difficult to debug such things. So what are we doing here? We are creating a Q contact, which is a queryable contact. We are saying query by state. We are building a predicate which says that find the state predicate, and we check that address is a list of addresses, right? It is not even single address. The addresses, we have primary address and secondary address. In that I am saying any of the address that state is starting with this state, give me all these things. So it looks very easy, right? If we are just building this query, here also we can sort by city name or whatever it is. So q sort again we can do q sort equal to q sort dot by q contact dot address list. We can sort by first name so that it is easy to here you can sort by age dot ascending. So the smallest stage will come first, right? So that the query that we are doing is against a subdocument, and we are sorting by a top value, which is age, and it is sort expression. Let us rerun this. It is just to make sure that find is in one, sort is in the parent document. So that's what we are trying to do here. Sorry, it is there, find by state. So if we see the URL part of it, contact DSL controller state, and it is a path variable. So it is a state. I think we have a state called Andhra here. Let us look into it. So where is the state? State is Andhra. State starts with Andhra. And if you see, the age is 30. Here the age is 48. So it is sorted by age ascending order and finding all the contacts who are living in this state. So it took very less time for us to build a search class based on any fields in the database, and it is very easy to build a sort or anything, because whatever we are doing is against the Pojo classes that we have it. So the next thing is find by age and state. So why are we looking into it? These are two different parameters. One is age, the other is state. One is in the parent document, the other is the subdocument part of it. And here we are doing age is greater than and state equal. So we are building logical operators here. So that becomes a significance here. So find by age and state. As usual, we know we are searching by the contactor, and then we are building a query predicate which says that find age predicate whose age is greater than or equal to this age is what saying. So if we want, okay, and finally find predicate, the second predicate we are building contact at address list dot any dot state state's name start with this. So we are going to find a contact whose age is greater than or equal to this number and who lives in the particular state. Now we have to do AND condition, right? That itself is another predicate, and the predicate is of type Boolean expression. By saying Boolean expression, this age predicate and this age predicate. We can have OR also, whatever we can, OR, all of, and. So now we are building AND condition. Let us do this AND only. Let me restart this once again. Rest all remains the same. Since it returns an iterable, I am using stream support to stream it and convert it into a list. Let us directly look into the endpoint. Find by age and state, whose age is greater than 40 and the state is Andhra Pradesh. I think we should have one contact. Age is greater than 40. Okay. So if I say age is greater than 20, we should get two contacts. So this person whose age is 30, this contact whose age is 48. So we have two contacts whose age is greater than 20 and the state is also Andhra Pradesh. Here also we can build a sort expression, use a sort expression as usual. Before building this predicate AND condition, we can do it, or after it doesn't matter, because sort expression is separate expression, right? Q sort equal to Q sort dot by Q contact dot probably name dot assembly, and pass on this parameter is called sort. If we read in this, we should be able to see the sorted layer, but full name. Full name is the field which we are persisting by concatenating the first name and the last name, which is not being passed immediately, but it is done here. In the same condition we do, so that we get two documents. We say P, which is the first name, which starts with P, the first name starts with V. So that comes second, this comes first. So it is sorted by full name. Let us look into the last thing. So this is to find an integer value between. So we need to find those contacts whose age is between starting number and the age is between the ending number. So this is an integer comparison. Last time we looked into an integer and a string comparison with a predicate of AND and a sort. Previously we looked into a string operation which is directly into the main document. Then we looked into searching for a string based on a subdocument. The third thing is fetching between an integer and a string. One is in the parent and the other is in the subdocument. Fourth thing that we are looking into is between starting and ending age, which is the parent document. These are integer searches, string searches, subdocument searches, array searches. We have handled almost everything here. So that is how these use cases I have chosen. So let us look into contact query by age between. Find first age should be greater than this or equal to this. The second age which is passed is less than or equal to this, and it has to be AND condition, right? It is greater than or equal to and less than or equal to. Then it comes a Boolean expression predicate. Age is greater than and age is less than and finally pass it to the predicate. You can sort by age ascending as well, it is easy, or age descending. Predicate sort, right? Sorry, q sort equal to q sort dot by q contact dot age dot descending. So the highest age will come first, and the least age will come to the last. Probably, yeah, that is okay. So let me rerun this query. If we go to the query DSL controller, we have similar, which is a path parameter of start age and the end age. So let us copy this, and we have a query. Now let me generate a new request. Find DSL age between get. Let me copy paste this, because we don't want to make a mistake while typing the URL. Let us copy this as well. From contact, paste this, and contact, paste this with a double slash. Remove it. Start age is 30 or 20, end age is 30. Let us see. Okay, we get all those contacts whose age is 25. The second person age is 30, which is less than or equal to, that is why we are getting it. Don't get confused. 30 means usually it is in for loop kind of condition where I is equal to and I is less than, so it is a strict. I used less than or equal to or greater than or equal to. So it is sorted by ascending. It is sorted in ascending order. Let us see. It is sorted in ascending order. I think it is not applying. Let me find it out. We can fix that later. So let me find the age between 30 31, so the 30 should not be included, right? And 50. So 35 is coming and 48 is coming, so 30 is not coming. Let us include 30 also, whether that condition is working or not. Okay, 30, so it is getting included, so it is greater than or equal to condition is working. So with this we have come to the end of this tutorial. Now in this tutorial, or till this tutorial, we have looked into insertion, finding. We have used 3 ways: directly use the repository, write the queries, and the query DSL. There are 3 ways to find it. Why did we elaborately look it to find? Because for us to go and update or delete, we need to find those documents. That's what we have done. With this, we have come to the conclusion of finding. The next tutorial we may look into update and delete. Thanks for your time. If you like it, if you see that this video is useful to you, please press the like button and subscribe to the video. Thank you for your time. Bye.